going straight to chapter 12, which is page 268. Here. We didn't have time to get all the way through this book, but I wanted to talk about estuaries, which is where we live. We live right next to an estuary. You ever heard that word before?
Mm-hmm.
Estuaries are where the fresh water from the land meets the salt water from the ocean. And there's actually several different types of estuaries. They're classified in different ways. Chesapeake Bay right here is called a drowned river valley. What happened is this is where a river, I guess it's the Chesapeake River, comes out and spills water out into the ocean. And what happened was it forms where a river goes into the ocean, it gets kind of wider and it kind of fans out like this. And the elevation gradually drops off. And about 18,000 years ago, the ocean level was not nearly as high as it is today because there was an ice age. And the ice, the polar caps, all expanded and spread throughout North America and over Russia and Europe. And the water from the oceans was all, or not all of it, but a lot of it was in the ice. And so the oceans were really low. And then when that ice age ended, all that ice melted and the water level came back up. And the water level basically drowned this river valley. This, where the river empties, is called a river valley. So that's what this is. It's a drowned river valley. And it's where fresh water is coming in from one side, salt water is coming in from the other. So you have kind of in-between water. Do y'all know what in-between water is called? Not salt, not fresh?
Brackish.
Brackish. And so that's a one type of estuary. That's actually the most common type of estuary, is a drowned river valley. Another type of estuary, the kind we have, is called a bar-built estuary. A bar-built estuary. What happened was, and this is a good example right here, these islands off the coast of North Carolina. They have a bunch of islands. Have y'all ever seen these or heard of these before?
Mm-hmm.
The name is slipping my mind here.
Kitty Hawk.
Say it?
Kitty Hawk?
Yeah, Kitty Hawk is there.
Okay.
But the islands are called the blah. Can't remember the name. The Outer Banks. These islands are called the Outer Banks. Yeah, Kitty Hawk, where the Wright brothers flew, was on these islands. And they're kind of like our island, St. Simon's. What they were is, when the ocean had retreated during the last ice age, way out here, when the ice melted and the water came back up, it pushed a lot of sand along with it and formed these barrier islands. And so it's behind the barrier islands that you get these estuaries. Here it is seen from a satellite or from space, I guess. I'm not sure, one of the two. But here's this long line of islands, and behind them you have areas where fresh water, you know, when it rains, the fresh water runs off, it goes into the ocean, so you got brackish water here behind the islands. That's what we have. We have our barrier islands, and then behind the islands we have marshes, which is a combination of fresh and salt water. It's brackish water. We have very extensive marshes. It's funny, their islands are a little bit different from ours. Their islands are all connected in a long line, and there's barely any space between them. Our islands have more space between them. You know, there's St. Simon's, and then there's some space, and then there's Jekyll, and there's a good mile or two in between the two islands. But their islands hardly have any space, and that's because their tides aren't as strong as ours. Our tides are so strong that any land or beach that builds up between the islands gets washed out by the next tide. We've got some of the strongest tides. We've got probably the strongest tides on the East Coast. Did y'all know that? Tidal currents. You ever hear about people getting killed by the tides out here? And swept away when they're walking out there on a sandbar or something?
Why here?
That's a good question. We are the farthest. If you look at the coast of the United States, here's Florida down here like this. We're the farthest inland, the farthest west that you can get on the East Coast. And so, when the tide comes in, like this, when the moon is in the right place and it pulls the oceans up, the tides come rushing in, and they kind of hit, the water kind of hits the edge here, and all goes to the middle here. It's kind of like, have you ever been pushing water off of a tennis court or something with one of those squeegees? And if you squeegee into the corner, the water all bounces off the sides and all ends up right in the corner, and it goes way up high on the wall right there in the corner. You know what I'm talking about? Squeegeeing. Love to squeegee. And so we're like the center of the squeegee, right where we are. And so we get these down here, and up here has lower tides, but right here in the middle, that's the highest tide and lowest tide. Because when it goes out of here first. And so that's why our tides are so great, and that's why there's space between our islands, and there is not space between these islands because they have a lot less tide. If we had lower tidal currents, Jekyll would be connected to St. Simon's, and you could just walk over there. Wouldn't that be cool? I like that. It'd probably be developed though. This is a tectonic estuary. This is San Francisco Bay. I just came from San Francisco. I was there over Thanksgiving. It was awesome. We went to Alcatraz. Is that Alcatraz right there? I think so. Went to see the redwood forest. Unbelievable.
I like the big tree that you drive through.
Yeah, we didn't go there. We didn't go to that part. We went to a different part. Anyway, here is San Francisco Bay, and this is it's a tectonic estuary. Remember plate tectonics? We got a big plate moving in and then under, and as that big plate goes under this plate, it pulls down the land a little bit. So if I get a plate coming in here, it kind of pulls this down, and so you have part of your land goes down, and you got kind of deep water right here. So that's what we call that, a tectonic estuary caused by plate tectonics. And so again, you have water running off the land whenever it rains here, and then salt water coming in through these little inlets, and so you end up with brackish water. And the final type is called a fjord. You ever heard that word before? Mm-hmm. Fjords are caused by glacial retreat. A glacier is a huge block of ice that's sometimes up to a mile thick. Imagine a piece of ice a mile tall. I mean, that's what glaciers are. Could you imagine that'd be pretty heavy? They're so heavy that as they move, because they slide, you see, they slide along. And as they move, they carve out rock. And the rock, with this sliding ice, gets carved up. And little pieces of the rock fall off as the glacier moves. And it'll carve out real deep channels into rock. And then when the glacier retreats, when it melts, because the earth gets warmer, you're left with this big carved out area. It's called a fjord. And that's what all this is right here. I think this is in Finland or Sweden or somewhere. Look at that. Fjords are really beautiful because, I mean, look how sharp that rock is. See, there was a glacier that came out through there. That's where it went through. And slid down and just cut that rock up. It's a very sharp edge now. But we don't have any fjords around here, so you may have never seen one. Okay, so let's talk a little bit about salinity in estuaries. Remember, the fresh water from rivers comes one way, or from runoff. Rivers and runoff, water runs off the land, or rivers bring it. Fresh water coming this way, salt water coming the other way. Salt water is heavier than fresh water. So the seawater runs underneath the fresh water. And you get what's called a salt wedge. Remember, seawater is 35 parts per thousand. That's what that means. And so if you're in a freshwater river, the surface might be fresh, but as you go further and further down, it gets saltier and saltier. So sometimes fishermen know about this, so they want to know where to catch the fish. Some fish hang out at different salt areas, and so if you might catch a fish on the bottom that's a saltwater fish, and a fish on the top that's a freshwater fish. Do you look at that sort of thing? No. I've seen them talking about it on some fishing shows before. But the fresh water is lighter than the salt water because the salt is heavy. Salt is heavier than water. Pulls the water down. And so here we go. There's this crab. This crab likes salt water. So it can get further inshore on the bottom than it can on the top. I don't know what it's doing here. Whoops. I guess it's moving into more brackish water here. Why do they have two pictures?
That's at high and low tide.
Oh, high and low tide. Okay. This is high tide here, and this is low tide here. Gotcha. The salt wedge in a typical estuary moves in and out with the tide. At high tide, the crab is covered by water with a salinity of 35 parts per thousand. At low tide, it's the lower salinity. Gotcha. The reading talks about the tides and how the tides go in and out. We talked about the tides earlier. It depends on where the position of the moon and the sun and the spinning of the earth. This is called a tidal bore. There are some places when the tide comes in, it comes in so furiously that you can see it. It's a wall of water moving down a river or a channel. And there's one right there. It's a tidal bore. B-O-R-E. And it can literally sweep you off your feet. That might be a wave that's several feet high. There are places where the tidal bores are so intense that it's dangerous to be out there. People have been killed by tidal bores. There's some place in Alaska, they said, where the tidal bore is like 30 feet high. And the water, when the tide comes in, the water just, it's like a tidal wave. This is talking about the sediments in the estuaries. So what happens is, you see areas like this all around St. Simon's. These are little tidal creeks and such. And what happens is the ocean water, the waves are powerful and can carry, the water comes in, and the tides, the tide comes in, and especially here we have really strong tides. And moving water can carry sediment, but when water is still, the sediment falls out. So the oceans can bring in sediment, and when they curl around behind the islands, so let's take a look here. We have our islands here. St. Simon's, Jekyll, Cumberland. What's the one north of us? Sapelo. So when the waters, the tides are moving pretty swift and sediment is brought in like this, but when it gets behind these islands into the marshes, the water slows down. And all the sediment falls out, you see. And so you get a lot of sediment built up behind the islands. And those are marshes. Because that sediment builds up over time. And so the elevation is a lot higher behind the islands, because that's where the water has slowed down. And then when the tide goes back out, it'll pull some of the sediment back out with it. And that's why our water looks brown around here, because it's got a lot of sediment in it. Our tides are so strong that when they come out, they pull sediment in. If you go down to Miami, there's not nearly as strong tides down there, because they don't have this squeegee effect. That's my term, by the way. You won't find it in the book. It's a bonus you get from me teaching you. They don't have the squeegee effect down in Miami, so the tides aren't as strong, and there's not nearly as much sediment in the water, so the water's blue there. It's real pretty. But here, there's a bunch of sediment, and so in the strong tides will pull it in and out, and so the water's brown all around here. It looks like that. The sediment is thick. Has anyone here ever walked through a marsh? We're going to get a chance to do it. We're going to go to the DNR, and we're going to walk in on one of the mud flats, so you'll kind of walk on the edge of the marsh. But the sediment's real thick. The particles are small and they stick together, and they won't let oxygen through very easily, because they're all stuck. They're so tiny and they're stuck together. It forms a barrier to oxygen. So much of the marsh soil is anoxic. Anoxic means no oxygen, and anoxic soil can build up. Plants and animals die and get broken down, and all these gases build up that normally wouldn't build up if there were oxygen penetrating the soil. And so you get smells, the sulfur smell that you smell, the kind of marshy smell. Those gases build up in this anoxic soil. And organisms have trouble with it. They have to get oxygen to their roots and such, the plants do, so they have different ways of doing it we can read about. So we have different types of species that live in different areas of the marsh. Stenohaline marine species are marine species that like completely salty water, that like to live at around 35 parts per thousand. We call that stenohaline. And, that's a saltwater fish, for instance. It can't live if the salt level isn't high. A euryhaline marine species can survive at a variety of salinities. All the way, can survive in the ocean and can still do well all the way up to, 5 parts per thousand here, which is almost fresh. There's a lot of organisms like that. These are marsh organisms that you see. Crabs, shrimp. There's a lot of different juvenile fish that are euryhaline species. This is good multiple choice stuff,
Would salmon be one?
Salmon would be, because they can tolerate both. Yeah, they can tolerate completely fresh water. So, yeah. Some species can only tolerate brackish water. They can't go all the way out into the ocean. Brackish water species, so they would be in here, doing well between fresh water and 15 or 20 parts per thousand. And then some species can't tolerate salt very well at all. So a freshwater species, you won't find many of them at more than 5 parts per thousand salt. Of course, the estuary varies. If we've had a lot of rain, it's going to have more fresh water in the estuary. And if it hasn't rained in a long time, it's going to have more salt. So organisms will move. Organisms will move up into the river or move further out toward the ocean, depending on what they want. Now, organisms, we call any organism either an osmoregulator or an osmoconformer. This worm here and this crab here sort of fit into the osmoconformer category. An osmoconformer is an organism that changes its salt level. In other words, if the salinity of the water is low, then the salinity of the organism is low. They try and match their body to the salinity, you see. If the salinity is high, this worm's body will be high salinity. So you basically match your surroundings there. It's kind of like a cold-blooded creature. The temperature matches the temperature of the surroundings. An osmoconformer, their salt level matches the salt level of the surroundings. This eel and this salmon are called osmoregulators, where they keep an osmoregulator keeps a constant salt level in their body. No matter what it is outside, they keep it constant. So if the salmon is in a really salty area, then it's going to have to do all the things it has to do to keep its salinity in its body down. It's going to have to excrete salt as it takes it in. It'll be removing salt with its gills, peeing out a lot of salt if it ever pees it. It's mostly salty urine. And then if the salmon is in real fresh water, then it's going to have to take in salt and pee out a lot of the fresh water. So osmoregulators try and keep the same. And then finally, the book talks about some of the plants. You'll recognize it? It's going to be on your exam. Spartina. Spartina has particular difficulties. It's one of the only plants that can really live in the marsh soil. Like I said, the marsh soil is thick. It doesn't let oxygen through. how's the Spartina going to get oxygen? Any idea? You may have noticed just from looking at Spartina before. Oxygen has to get to the roots of this plant. How can it get there? The roots of this plant go real deep and there's hardly any oxygen in the soil.
It's like a tube.
It's got a tube. Have you ever seen these tubes? It's got a tube. The tube starts right about here, right just above the mud line, and goes way down into the soil, and it's hollow. And it goes down there, and air goes into the tube, you see, and then the tube branches off and goes to all the roots, so that oxygen can get to the roots through the tube. And then, so you often see those tubes. What happens when the plant dies, the tube will become dislodged in the tide. The tube is kind of tough. And the leaf blades will decompose, and you're just left with the tube. And then the tube gets yanked out of the substrate when the tide comes in and out, and it floats around, and it washes up on the beach. And you see those tubes laying on the beach. Y'all seen those? They're all over the place. Those all came from the marsh. And usually the leaf blades have decomposed by that time, because it takes a long time to get that tube to wiggle out of the mud and to wash out. So the leaf blades have decomposed by that time. Sometimes you'll see the whole plant washed up, especially after a storm. Go walk on the beach after the next big storm, and you'll see. Sometimes you'll see whole Spartina plants. So that's how they get oxygen down to their roots. They also have ways to excrete salt. If you ever go to a Spartina, take your fingers and just kind of slide it up the plant like that, you'll get a bunch of salt grains on it. And you can lick it, and it tastes salty. I don't know why you would want to do that, but maybe you got some crackers with you. You need some salt on them. The leaves will excrete salt from their leaves, and so it's able to tolerate the real salty condition because it gets rid of the salt. And it's one of the only plants that has evolved to do that. And so when you go out and look at a marsh, there's only one type of plant out there, or two or three types maybe. And that's why the marsh looks all the same. It looks all even. Because that's the only type of plant that can grow there. There's actually a couple types, but Spartina around here does the best. What's that? Glasswort. Remember that? That's another plant. Another way to tolerate the conditions of the marsh is to store water inside your leaves. You know what we call that when water is stored inside your leaves? Succulent. These are succulent leaves. And you can store fresh water. They have real waxy coverings so the water can't get out. And so whenever it rains, whenever fresh water comes down, they store it. And the body of the plant is lower in salt than the surroundings. It's an interesting way to do that. It's still pretty salty, and so you can buy these things and taste them, and they taste nice and salty. Ha! There's a cop pulling me out of the mud. That's not really me. Just joking. Just got that off the internet. That was fun. All right, so you read through page 273. Okay?